Good afternoon, advanced algebra students. I'm super happy that we are continuing to work through chapter 6 in our advanced algebra book. We know from our previous lessons that logarithmic functions are the inverses of exponential functions. We also know they can be used to find the value of variable exponents. So this lesson, lesson 6.4, is going to further explore logarithmic functions, how to determine their key features, graph them, find their inverses, and compare them. So let's talk about, let's do an example here. We've got y equals log base 2 of x. And we want to graph this function. We want to identify the domain and range, list any intercepts or asymptotes, and describe the end behavior. Label 2 points on the graph. So what I typically do is I rewrite this as log base 2 of x equals y. I put it in that order, so then it's a little bit easier for me to draw my heart shape. And I can see that this is equivalent to 2 to the power of y equals x. Then what we typically do when we are dealing with these kinds of functions and want to graph them, in this case, we would put two values in for y, 0 and 1. When y is 0, x is going to be 1. And when y is 1, x is going to be 2. So then I can easily graph these points. So I want to go, let's see, 1 over and 0 up, and then 2 over and 1 up. Now, in order to graph this, we do kind of need to know the basic shape of a logarithmic function. This is going to be our basic shape. The domain is basically x greater than or equal to 0. Notice that x is never going to be negative. The range is all real numbers. The asymptote here is the x-axis, or we can think of that as the line y equals 0, whichever you prefer. And in terms of the end behavior, let's go ahead and notice that as x approaches 0, y approaches negative infinity. Notice that x will never actually equal 0. And as x approaches positive infinity, y approaches positive infinity. So that would be an example of looking further at that logarithmic function. Let's do another example, example number 2. Y equals log base 1/2 of x. Again, I like to kind of flip the order here to make it easier for me to evaluate and then draw my heart shape. So I have 1/2 to the power of y equals x. And again, I'm going to do a t-chart with two values for y, 0 and 1. When y is 0, x is going to be 1. And when y is 1, x is going to be 1/2. So I'm going to go ahead and plot these points. I'm going to go 1 over and 0 up, and 1/2 over and 1 up. Now in this case, I still have the same asymptote. And by the way, you know what I'm noticing here? On this last example, I wrote down the asymptote incorrectly. This asymptote should have been the y-axis, or the line x equals 0. You know, it's funny because we are going over section 4.1 and 4.2 right now in class. And then oftentimes in that case, our asymptote is y equals 0. So I was kind of stuck in that mode. But clearly, this is the y-axis that is our asymptote here. So make sure that you've got that corrected in your notes. All right, back to this example here, example number 2. Again, we're going to have the same asymptote that we had before, but this one is kind of flipped here. So we're going to say that the domain is, again, x greater than 0. The range is, again, all real numbers. The asymptote, the correct asymptote here, asymptote is the y-axis, or the line x equals 0. Let's see here. In terms of the end behavior, as x approaches 0, y is going to approach a positive infinity. And as x approaches positive infinity, y approaches negative infinity. So this is how we can kind of convert back and forth between exponential and logarithmic functions and graph them. Let's go ahead and do a couple more examples. I think we're going to do a total of 6 on this notes. So we're a third of the way done. All right, example number 3. We're going to describe the graph in terms of the transformation of the parent function f of x and compare the asymptote and x-intercept of the given function to the parent function. So for example 3, let's use f of x equals log base 2 of x, and then we'll have g of x be log base 2 of x plus 3. Now, let's go ahead and graph y equals log base 2 of x. Now, we graphed this in example number 1. So we already did y equals log base 2 of x. On that one, we had a t-chart where x was 1 and y was 0, and x was 2 and y was 1. So I'm just going to quickly graph that one because we already did that. I'm going to do this in a dotted line, however, because in this particular case, this is just kind of our starting point. Now, if I want to graph y equals log base 2 of x plus 3, all I have to do is shift everything 3 to the left. So if I do that, I'm just going to shift this point 1, 2, 3 spots to the left, and this one 1, 2, 3 spots to the left. And then my final graph will look like this. So it's the same graph that we did in example number 1, but g of x is translated 3 units left. Our new asymptote then, so the new asymptote is x equals negative 3, and the x-intercept is x equals negative 2. Okay, let's do example number 4. So in example number 4, f of x is equal to ln x, and h of x is 5 times ln x. Let's go ahead and take a look at this one right here. I can write this as y equals log base e of x, or log base e of x equals y, or e to the y equals x. If I do a little t-chart for this and set y equal to 0 and 1, when y is 0, x is going to be 1, and when y is 1, x will be approximately 2.8. Now remember, e is not equal to 2.8, it is approximately 2.817, that is, we don't ever use that value. We use the actual E button on our calculator. So actually it would be, I should have put probably 2.7. It's 2.718. So let's just go ahead and change that to be more accurate. Let's change that to 2.7. Okay. So on this graph, if we graph the parent function, we're going to go 1 over and 0 up, and then 2.7 over and 1 up. And this will give us our starting point. Now, the parent function is being stretched by a factor of 5. So for example, each point that I have would have a vertical stretch of 5. I'm still going to go to the same point here. When y is 0, stretching it doesn't change anything, but here instead of y being 1, y is going to be 5. So I would put a dot up here, and this would be the graph once I've stretched it. So we're going to say that there is a vertical stretch of 5. All right, let's do a couple examples where we have to find inverses of a function. So there's 2 basic steps to finding an inverse. The first is to switch the x and y, and then after that, we go ahead and solve for y. So let's have this be example number 5. You can think of this as y equals 10 to the x plus 1. And I'm going to again put the base on the left. I find it easier to see what's going on then. And then I can rewrite this here. So this would be log base 10 of y equals x plus 1, or log of y, log base 10 of y. Did I do that correctly? Oh, yeah, let me go back. I need to switch my x and y. So I did write the first part out correctly, but now I need to switch the x and y values. So instead of y, I'm going to put an x here, and instead of x, I'm going to put a y there. So let me write those steps out so we don't forget. The first thing is to switch your x and y, and then the second step is to solve for y. So we do need to switch our x and y, and now we're going to solve for y. So we'll rewrite this as log base x, 10 to the y plus 1 equals x. So log base 10 of x equals y plus 1. And then in order to solve for y, we would subtract 1, and we would get y equals log base 10 of x minus 1. If you want, you can just write this as y equals log of x minus 1, because you don't have to include the 10. All right, let's do another example here. Example number 6, and I think this will be our last one. So if I have g of x equals log base 7 of x plus 5, I can think of this as y equals log base 7 of x plus 5. And then I need to do my 2 steps. I need to switch the x and y. So I'm going to write this as x equals log base 7 of y plus 5. And then I'm going to put this on the left. And then I want to reformat. So I'm going to do 7 to the power of x equals y plus 5. And then I would subtract 5 from each side. And I would get that y is 7 to the x minus 5. Okay, I think that's pretty good in terms of examples for lesson 6.4. Thank you so much.